Okay, so in this video, I want to talk about position, velocity, acceleration. And it's sort of like an application to physics, although it's a very simplified application of physics. If you've studied physics before, or maybe you're in physics right now, you're definitely going to do things that are a little bit more complicated than what we're going to do. But there are problems that relate to physics on the AP exam. And so I just want to make sure we're sort of all on the same page. And it's very elementary, very introductory physics, and a lot of this motion that we're going to talk about, like velocity and acceleration, it's of a particle like on a straight line. Okay, so and a lot of times the straight line could be the x-axis or the y-axis, and so I'm going to use that as sort of a reference up here. Obviously, there's other kinds of motion, like circular motion, or if there's like both components vertically and horizontally at the same time, like more of like a free fall or like free body motion diagrams that maybe you guys do in physics. But our motion will just be along a straight line. So let's say we're at position 1. So and that's exactly what like position stands for. Is it's your placement. Where are you at? So I could say position is placement. Where is it located? It has nothing to do with distance. My dot is at 1. That right now, or my dot is at 2, or my dot is at 3. It tells me where to find the dot. That's position. Now, if I'm measuring that as a length from another point, then I have distance. So if I go to distance, distance is the physical length between 2 points. Pen is so slow today. And it's going to always be positive. So if I'm measuring 0.3 down to -2, this right here has a distance of 5. Now, if I want to keep track of order, then I'm going to talk about displacement. So displacement is a measurement between 2 points, but it's the final position minus the starting position. So final position minus starting position. So in this case, I could have a negative displacement. If I end up farther to the left than where I started, I'm going to have a negative displacement. So if I start at 3 and end at -2, so start at 3 and end at -2, even though it's a distance of 5 units, my final position was -2. I subtract my starting position, and so I end up getting a displacement of -5. Displacement can be negative. Distance is always positive. Now, if you look at velocity and speed, they're very closely related to displacement and distance. Velocity is the change in displacement over time, where speed is the change of distance over time. So velocity is the change in displacement over time, where speed is the change of distance over time. So it's like a ratio, right? Change in distance over time. Meters per second is a measurement of velocity and speed. But because velocity is based on displacement, which could be negative, so could your velocity values. And speed, because it's based on distance, is always going to be positive. So I might write that down as well. That this one is always positive. Just like distance is always positive. Okay. Now, average speed versus average velocity, and I'll do the average velocity first. So average velocity could be final position minus starting position divided by elapsed time, total time. Okay. Your average speed, though, is the total distance traveled divided by the total time. And again, because speed is based on distance and distance only, that's going to stay positive. So this is the total distance divided by total time. And so again, this one's always positive, where the other one could be negative depending if you're going to the left, or it could be 0. Like I think about running the 2 mile on the track. You go 2 miles, but your displacement is 0. So your average velocity is 0. It's kind of sad. But your average speed would be different because you're just looking at the 2 miles over how long it took you to go. And then the last one, acceleration, is the change in velocity over time. Oh, my pen is just not cooperating. Okay. And because it's a change in velocity, which could be negative or 0, so could your acceleration. Okay. Now, a very common question is, you have this particle on the, and maybe it's moving back and forth, and you're giving some information, and the question, is it speeding up? And speeding up is more than just acceleration. Speeding up, you have to look at both the velocity and the acceleration, because I could be speeding up in either direction. So if I'm speeding up, I need to check, do the signs of acceleration and velocity match? So speeding up, I would be speeding up if the signs, so positive or negative, of velocity and acceleration match. So if they match, both positive or both negative, you're speeding up. Okay, if one is positive and one is negative, it doesn't matter which one is which, then you'd be slowing down. Okay, so with particles speeding up if the signs of velocity and acceleration match. And again, the signs meaning positive versus positive or negative versus negative. One means you're speeding up into the right versus one speeding up to the left. Okay, now the next example, I'm going to give you some velocity and acceleration functions. And we could actually find these because if I'm looking at a physics application, I know the derivative of position could represent velocity, and then the derivative of velocity could represent acceleration. But I've already done that for you. And so I'm going to give you a graph for velocity, an equation for velocity, and an equation for acceleration. And I want to draw a sign chart here. And it's just going to go from 0 to 10. And I'm going to draw them on sort of like on top of each other. So this top one would be velocity, call it v of t, where the bottom would be acceleration, call it a of t. Starts at 0, ends at 10, because that was the given domain. And I want to know about the critical values. Like, when is the velocity 0 to divide up this number line? So I look at my equation here for velocity, which is this one right here, and the velocity is 0 when t is 2 or when t is 4. So I'm going to mark those spots on my number line. So t equals 2, maybe right here, and t equals 4 is right there. Now, in terms of acceleration, I also noticed that t equals 2 is a 0 as well. So I'm going to keep track of that one down in acceleration at 2. And 10/3, it's like 3 1/3. So it's not quite to 4 yet. So I'll put 10/3 right there. And so I want to look at the sign, positives versus negatives of velocity, and same thing with acceleration. Now, there's a lot of different ways you can teach sign charts and think about sign charts. Ultimately, you're trying to test a point in the region. So let's say we test something between 0 and 2 on velocity. Pick any representative in that region, and it's going to behave the same way. So let's say you pick 1. And if you put 1 into the equation for velocity, and you decide, okay, how big, what's happening with 1? So 1 minus 2 is -1, but I'm squaring it, becomes +1. And 1 minus 4 is -3. So 1 times -3, it's negative. So all of this region here would represent negative velocity, which means it's moving to the left. Okay. Pick a representative in the next region, like over here, like between 2 and 4, like let's say 3. If you put 3 into this function, 3 minus 2 is 1, and 1 squared is still 1. 3 minus 4 is -1, and so I get 1 times -1, so it still remains negative. So everything in this region is also negative. And then finally pick a representative in that final region over here between 4 and 10. So maybe pick like 5 or 6 or 7. It does not matter. And you put it into the function. So like 5 minus 2 is 3. 3 squared is 9. 5 minus 4 is 1. So 9 times 1 is 9. It's a positive value. So now everything in this region is positive. So again, velocity by itself does not tell me it's speeding up. It just tells me a direction. So I'm moving left, and then I'm moving to the right. And at each of these times, I'm momentarily pausing, and then either moving to the left or the right. Now, we need to match up acceleration as well. So now I'm going to pick a representative down, right down in the, let's pick, I guess this color, this region right here. So again, maybe pick 1, put it into the acceleration function, which is right there. So 1 minus 2 is negative 1. 3 minus 10 is negative 7. So I have negative 1 times negative 7, which is actually a positive 7. And not that I care that it's necessarily 7, but the fact of the matter is that it's positive. So I know this is positive. And then to pick something between 2 and 10/3, 3 works. So let's go ahead and look at that region. I'm sorry. So like 3 minus 2 is 1. 9 minus 10 is negative 1. So that's going to be a negative value. And then picking anything in this region over here, let's say like 5 again. 5 minus 2 is 3. 15 minus 10 is 5. Again, a positive number. So acceleration by itself doesn't indicate if it's speeding up. If I want it to be speeding up or slowing down, I need to check the signs of the velocity and acceleration. Now, it's nice that I have these lined up on top of each other because now I can kind of divide this up. So between 0 and 2, I know exactly what your velocity and your acceleration is doing. Between 2 and 10/3, I can see what's happening. Between 10/3 and 4, I can see what's happening. Between 4 and 10, I can see what's happening. So now, if I take a look, it says, is the particle speeding up, slowing down, or stop when t equals 2.5? So 2.5, right? 2.5, I guess I can pick this one right here. It's like somewhere here, 2.5. It's greater than 2, but less than 10/3. I've got a negative velocity and a negative acceleration. So because they both are negative, this is actually speeding up. So I could say it's speeding up, and it's speeding up to the left. And how do I know? My justification would be both v of 2.5 and a of 2.5 are negative. And so because they're both negative, I'm actually speeding up towards the left. And not that it asks us that, but I know it's to the left. I'm speeding up. So I'm getting faster and faster in that negative direction. Okay. Now, how many times does a particle change directions? So changing directions, you need to look at the change in the velocity, right? The sign of your velocity. Velocity determines the direction. So from 0 to 2, I'm moving in the left direction, and I pause. And then from 2 to 4, I'm still going the left direction, and I pause. But right here at 4, I then go back to the right. So it only changes once or one time, and the time that it changes is when t was 4. Now, I don't have to analyze acceleration. I just have to look in when did the velocity change signs. Okay. And then the last one says, for what values is the particle slowing down to the right? Well, moving to the right or moving to the left, that direction's always determined by velocity. So if I want to be moving to the right, I need to make sure my velocity would be positive. If it said moving to the left, then I'd make sure my velocity were, if it was moving to the left, then I make sure my velocity was negative. Okay. Now, as soon as it says slowing down, I know my sign has to be the opposite value. So if I'm positive velocity, then I should have negative for my acceleration. So I'm looking for negative acceleration. So when do I have positive velocity but negative acceleration? So go up here. Do I have negative velocity, negative velocity? Aha, the only time I have positive velocity is here, and I look down below When is there negative acceleration in this interval? There isn't. So it's never moving in this direction. So I'd say never, because I don't have the evidence of the required positive velocity with negative acceleration. I thought he was able to erase that. There we go. Okay, so I'd just say never. Okay. Now, obviously that took a little bit of time because I really wanted to go through a detailed explanation. For some of you, maybe you already knew this. And so it was just, okay, yeah, I already know this. But for others, it's good to have that strong basis. So I'll go ahead and stop this first video here, and then I'll record a second video for the example 2 and example 3 when you're analyzing a position versus time graph and a velocity versus time graph. And again, maybe you've done this in physics, and so it should seem relatively familiar to you.